Hello everyone, I hope everybody is fine. We continue our lectures with the techniques of limit computation. So this topic is about one-sided limits. We have a function, a logarithmic function, 4 times log of x minus 2. We want to find the limit of this function when x approaches 2 from right-hand side. So if I draw the graph of this logarithmic function, you know that because of the 4, the basic or parent logarithmic function is vertically stretched by a factor of 4, and also it is translated horizontally to the right by 2 units. So the shape of the graph would look like something like this graph here, and the vertical asymptote also horizontally shifts to the right by 2 units as well. So you know that the y-axis, whose equation is x equals 0, is the vertical asymptote of the logarithmic function, the basic logarithmic function. But because of the horizontal shift to the right, the graph is shifted to the right by 2 units, and this is how the graph looks like. And you may see here that on the left-hand side of this vertical asymptote, there is absolutely no graph whatsoever. And the whole graph is on the right-hand side of the vertical asymptote. So here when it says x approaches 2 from right-hand side, this is a right-hand limit, actually. This is when x approaches 2 from values that are greater than 2, not from values that are less than 2. So, for example, x could be like something like 2.001, which is very close to 2, but it's actually greater than 2, and on the graph, it will be on the right-hand side of the vertical asymptote. So this is a right-hand limit. And we want to find out what the limit is. By looking at the graph, we can see that as x approaches 2 from right-hand side, for example, x is 2.1, and then gets closer, 2.01, and then gets even closer, 2.0001. We see what happens to the graph. The graph goes down all the way towards negative infinity. So we're going to say that this limit is actually negative infinity, or inside brackets, we can say D and E, which means that limit does not exist. So this is one example of a right-hand limit or one-sided limit. In fact, in this case, it doesn't even make sense to say that x approaches 2 from left-hand side, because on the left-hand side of the vertical asymptote, we don't even have a graph, okay? The function is totally undefined on the left-hand side of the vertical asymptote, whose equation is x equals 2. So we say limit does not exist. To be more specific, the answer is negative infinity. This is just another example. We have a rational function. We want to find the limit, but here x approaches 4 from right-hand side, and once again x approaches 4 from left-hand side. So this is the right-hand limit, and this is the left-hand limit we want to find. So the first thing we do is to factor the numerator and the denominator, because if you use direct substitution method, and if you substitute 4, now 4 squared is 16. 16 plus 4 is 20. 20 minus 12 is 4. So the numerator is going to be 4. The denominator is going to be 16 plus 12, which is 28, minus 7 times 4, which is negative 28. Add them up, it will be 0. So the denominator approaches 0 if x approaches 4. Now it doesn't matter from left side or right side. The denominator approaches 0. The numerator approaches actually 4 as we calculated, because 4 times 4 is 16. 16 plus 4 is 20. 20 minus 12 is 8. Oh, yes, the numerator approaches 8 actually. So in anyhow, the numerator is a constant, but the denominator approaches 0. So we can say actually that this limit doesn't exist right away. So we can clearly say that this limit does not exist, because the denominator of this rational function approaches 0. The numerator approaches a constant number, a limited number, such as 8, as we found. So the answer for sure is infinity, and the limit does not exist. But we want to be more specific. We want to see, okay, is it positive infinity or is it negative infinity? Which one? So even if x approaches 4 from left-hand side, as you see here, again, the numerator is going to approach 16 plus 4, which is like 20 minus 12 is going to be 8. So again, the numerator approaches 8, but the denominator approaches 0. So again, the answer is infinity. Again, we say the limit does not exist. But the thing is that we want to find the right hand, we want to find if this infinity is positive infinity or is it negative infinity. In the previous exercise, you saw the answer was negative infinity because the graph was going all the way downwards towards negative infinity, but it could be the other way, going up towards positive infinity. So that's what we want to be more specific here. And in order to figure this out, we are going to do the factoring to see what factors we have here. So I'm going to say limit of the numerator can be factored as x and x. So two numbers add up to 1 with a product of negative 12. I believe it's positive 4 and minus 3. And in the denominator, we can say, again, negative 4, I believe, x plus 4. No, x actually minus 4 and x minus 3 because they have to add up to negative 7. So x minus 4 and x minus 3. Two numbers add up to negative 7 with a product of positive 12. So now here, if you simplify x minus 3 from top and bottom, you would end up with limit of x plus 4 in the numerator and x minus 4 in the denominator. So when x approaches 4 from right-hand side, again, the numerator would approach 8, the denominator would approach 0. But the thing is that if x approaches 4 from right-hand side, it means that x is approaching 4 from values that are greater than 4, such as 4.001, something like that. So that means that the denominator would be very, very close to 0. It would be very small number, but end of the day, it will be a positive, very small number. So the numerator is positive, the denominator is approaching 0, but positive 0. Therefore, the whole rational function would approach infinity because its denominator is getting very, very small. What do you expect? The whole fraction is going to explode, but the top and the bottom of the fraction will always have a positive sign, meaning that the answer would be positive infinity. So we're not saying limit does exist. Of course, it doesn't exist. And we know that this rational function, as x approaches 4, is going to approach infinity. But what type of infinity? The answer was positive infinity because both numerator and the denominator have or will have a positive sign if x approaches 4 from right-hand side, that is from values that are greater than 4. Now, same discussion can happen for the other case, limit of x plus 4 over x minus 4 when x approaches 4 from left-hand side. This time, if x approaches 4 from left-hand side, that is from values that are less than 4, one example could be 3.999. If x is 3.999 and then minus 4, the denominator will be very, very close to 0 again, but this time it's going to be a negative 0. A number that is very, very close to 0, but it's on the left-hand side of 0, that is negative. The numerator is going to be still approaching 8. So as a result, the answer will be negative infinity. So here, now the puzzle is solved. If x approaches 4 from right-hand side, the answer is positive infinity. If x approaches 4 from left-hand side, the answer is negative infinity. So we call this right-hand limit. So this one is right-hand limit, and this one is left-hand limit, okay? We know that limit of this function doesn't exist, okay? So if somebody says in general, what is the limit of this function when x approaches 4, okay, in general, we're going to say, well, this limit does not exist. And the whole rational function approaches infinity. That's what we're going to say. But if they said, okay, be more specific, is it positive infinity or negative infinity? We're going to say, well, it depends on x approaching from right side or left side. If x approaches 4 from right-hand side, yes, the answer is positive infinity. If x approaches 4 from left-hand side, x approaches negative infinity. So in any case, limit doesn't exist, but we can be very, very specific if we take the right-hand limit or left-hand limit of the function. This is another example here. X approaches 5 from right-hand side. So we know that the denominator is going to approach 0 for sure. The numerator if you just plug in 5 for x, that's going to be 25 minus 24, which is 1. So the numerator approaches 1, the denominator approaches 0. So it's out of question. It's very clear that the answer is going to be infinity, and limit does not exist. Okay, so that is for sure. But if you want us to be more specific about the sign of the infinity, we can actually find the specific answer. We can say, okay, if x approaches 5 from right hand side, it could be something like 5.001. So 5 minus 5.001 is like a very, very small number close to 0, but it's negative end of the day. The numerator approaches 1, the denominator approaches negative 0, so the whole fraction has a negative sign. The denominator approaches 0, the whole fraction approaches infinity, so the answer is negative infinity. In the denominator, in the next part, if x approaches 5 from left-hand side, then what could a possible value for x be? 4.9999. So 5 minus 4.9999 is a very small number, close to 0, but it is positive end of the day. And positive divided by positive is positive. Therefore, the left-hand limit is positive infinity. The right-hand limit is negative infinity for this function. And in general, this limit does not even exist at all, of course. So I hope you understood how we calculate left-hand limit and right-hand limit in different scenarios. And we will continue with other techniques in the future lectures. Thank you for your attention.